It's me again, Ms. Yanin. Last week we are done discussing solving quadratic equation using extracting the square root method and factoring. But the question is, what if the given quadratic equation isn't factorable? Well, this time I'll be teaching another two methods in solving quadratic equation, whether the given quadratic equation is factorable or not. First is to solve quadratic equation using completing the square, and the other one is to use the quadratic formula. Here are the steps in solving quadratic equation using the completing the square method. First, you have to take a look at a. If a is not equal to 1, you have to divide all terms by a. Next is to isolate the constant using addition property of equality. And the third is to complete the square. Fourth is to factor the perfect square trinomial. And after that, you have to extract the roots using the square root property. And lastly, you have to solve for the unknown variable. We'll now be solving quadratic equation using completing the square method. Our first equation is m squared plus 6m plus 3 is equal to 0. Our first step is to divide all terms by 1 if a is not equal to 1. But for this case, the coefficient of the quadratic term is equal to 1. So there's no need for us to perform step number 1. We'll now be proceeding to our step number 2, which is to isolate the constant using addition property. In this case, our constant is 3. So we'll be getting the additive inverse of positive 3, and that is negative 3. Negative 3 will now be added to both sides of the equation. 3 plus negative 3 is equal to 0. So we have now m squared plus 6m plus blank for completing the square. And 0 plus negative 3 is equal to negative 3. Now we'll be completing the square. We have to use the formula for the constant, the square of b over 2. In this case, b is equal to positive 6. We'll be substituting 6 to b, giving us 6 over 2 squared. 6 divided by 2 is 3, and the square of 3 is 9. We'll now be adding 9 to both sides of the equation. Next step is to factor the perfect square trinomial. Our perfect square trinomial here is m squared plus 6m plus 9. To factor the perfect square trinomial, we have to get the square root of m squared, and that is m. Next, we'll be copying the sign of the linear term, positive. And lastly, we'll be getting the square root of 9, which is 3. Of course, we'll be simplifying negative 3 and positive 9. Negative 3 plus 9 is equal to 6. Our next step is to extract the roots using the square root property. So we'll be getting the square root of m plus 3 squared and the square root of 6. The square root of m plus 3 squared is m plus 3, and the square root of 6 is positive negative square root of 6. The factors of our radicand 6 aside from 1 and 6 are 2 and 3. 2 and 3 are both not perfect squared number, so square root of 6 is said to be in its simplest form. Next is to solve for m. We can do that if we were to add both sides of the equation with the additive inverse of positive 3, and that is negative 3. On the left side, we have positive 3 plus negative 3. It is equal to 0. So in here, we have m. On our right side, we have positive negative square root of 6 plus negative 3. We'll be writing first negative 3, followed by positive negative square root of 6. In here, we have two values of m. The first value is negative 3 plus the square root of 6. And the next value is negative 3 minus the square root of 6. We can see in here the symbol plus minus. So it can be separated to positive and negative. Next equation is x squared minus 12x plus negative 1. Our first step is to divide all terms by a if a is not equal to 1. In our equation, a, which is the coefficient of x squared, is equal to 1. So there's no need for us to divide the terms by a. Next step is to isolate the constant using the addition property of equality. In here, the constant is already separated, so there's no need for us to do step number 2. 3, which is to complete the square. Using the formula square of b over 2. Our b in here is negative 12. So we'll be substituting negative 12 to b, giving us negative 12 divided by 2 squared. And negative 12 divided by 2 is negative 6. The square of negative 6 is 36. So we'll be adding both sides of the equation by 36. Next step is to factor the perfect square trinomial. Our perfect square trinomial in here is x squared minus 12x plus 36. To factor this, first we'll be getting the square root of x squared, which is x. Copy the sign of the linear term, minus, and get the square root of 36, which is 6. For negative 1 plus 36, we have 35. Next step is to extract the roots using the square root property. So we'll be getting the square root of x minus 6 squared and the square root of 35. The square root of x minus 6 squared is x minus 6, and the square root of 35 is positive and negative square root of 35. The factors of the radicand 35, aside from 1 and 35, are 5 and 7. Both are not perfect square numbers, so square root of 35 is said to be in its simplest form. Next is to solve for x. To do that, we have to add the additive inverse of negative 6 to both sides of the equation, and that is 6. In our left side, we have negative 6 plus 6, that is equal to 0, so we have in here x. In our right side, we have plus minus the square root of 36 plus 6. We'll be writing first 6, giving us 6 plus minus the square root of 35. We have two values of x in here. First is 6 plus the square root of 35, and 6 minus the square root of 35. Our next equation is 4z squared minus 12z plus 9 is equal to 0. For the first step, if a is not equal to 1, divide all terms by a. And here, a is equal to 4. So we'll be dividing all terms by 4. For z squared divided by 4 is z squared. Negative 12z divided by 4 is negative 3z. And 9 over 4 is still 9 over 4. Why? Because there is no other common factor of 9 and 4 aside from 1. So 9 and 4 is said to be in its simplest form. And 0 over 4 is equal to 0. Our next step is to isolate the constant. Our constant in here is 9 over 4. But notice in here that 9 is a perfect square number, and so is 4. So before doing the isolation process, we'll be checking whether there is a relationship between 9 over 4 and the square of b over 2. In b over 2 squared, b is equal to negative 3. Negative 3 squared is 9, and 2 squared is equal to 4. Therefore, z squared minus 3z plus 9 over 4 is already a perfect square trinomial. So we'll be proceeding to the next step, which is to factor the perfect square trinomial. To do that, we'll be getting the square root of z squared, which is z. Copy the sign of the linear term, which is negative, and get the square root of the constant, which is 9 over 4. To do that, you'll be getting the square root of both numerator and denominator. The square root of 9 is 3, and the square root of 4 is 2. So the square root of 9 over 4 is 3 over 2. Of course, we'll be copying 0. Next is to extract the roots using the square root property. We'll be getting the square root of z minus 3 over 2 squared and the square root of 0. The square root of z minus 3 over 2 squared is z minus 3 over 2, and the square root of 0 is 0. Next step is to solve for z. We can do that by adding the additive inverse of negative 3 over 2 to both sides of the equation. Negative 3 over 2 plus 3 over 2 is 0, so we have in here z. And 0 plus 3 over 2 is 3 over 2. So the value of z in here is 3 over 2. Next will be solving quadratic equation using the quadratic formula x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Number 1, write the equation in the form ax squared plus bx plus c is equal to 0. And then identify a, b, and c. After that, you have to substitute the value in the quadratic formula. And of course, you have to simplify the equation. Our first example is n squared is equal to negative 3n minus 4. First is to write the given equation in the form ax squared plus bx plus c is equal to 0. To do that, we have to add the additive inverses of negative 3n and negative 4 to both sides of the equation. The additive inverse of negative 3n is positive 3n, and the additive inverse of negative 4 is positive 4. Negative 3n plus 3n is 0, and negative 4 plus 4 is also equal to 0. So on our right side, we have 0. On the left side, we have n squared plus 3n plus 4. Next is to identify a, b, and c. From the standard form ax squared plus bx plus c is equal to 0, we have to compare the position of the resulting equation n squared plus 3n plus 4 is equal to 0. By doing this, we can easily determine the values of a, b, and c. So in here, a is equal to 1, b is equal to 3, and c is equal to 4. After getting the values of a, b, and c, we'll be substituting these values in the quadratic formula. N is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. b is 3, a is 1, and c is 4. Simplifying this equation, we have negative 3, 3 squared is 9, and negative 4 times 4 is negative 16. 2 times 1 is 2. Next, we'll be simplifying the radicand. 9 minus 16 is equal to negative 7. Since the radicand is negative, we can say that the equation has no real roots or no real solutions. Our next example is 5n squared plus n is equal to 7n minus 1. First thing for us to do is to write the given equation in the form ax squared plus bx plus c is equal to 0. To do that, we'll be adding both sides of the equation by the additive inverses of 7n and negative 1. The additive inverse of 7n is negative 7n, and the additive inverse of negative 1 is positive 1. Now we'll be simplifying the equation. 7n plus negative 7n is equal to 0, and negative 1 plus 1 is also equal to 0. So the right side will be equal to 0. On the left side, we'll be simplifying n plus negative 7n, and that is negative 6n, giving us the resulting trinomial 5n squared minus 6n plus 1. We'll now be identifying a, b, and c. Based on our standard form ax squared plus bx plus c is equal to 0, we'll be getting the values of a, b, and c. In here, we can see that a is equal to 5, b is equal to negative 6, and c is equal to 1. We'll now be substituting the values of a, b, and c in the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. Negative 1 times negative 6 is 6. Negative 6 squared is 36. Negative 4 times 5 times 1 is negative 20. And 2 times 5 is equal to 10. Simplifying the radicand, 36 minus 20 is 16. 16 is a perfect square number. so we can get its square root, which is positive -4. We now have the value of n, which is equal to 6 plus -4 all over 10. For the first value of n, we have 6 plus 4 all over 10. For the next one, we have 6 minus 4 all over 10. For the first value of n, we have 6 plus 4, which is equal to 10. And 10 over 10 is equal to 1. So the first value of n is 1. For the second value of n, we can see in here 6 minus 4, which is equal to 2. We'll now be simplifying 2 over 10. The common factor of 2 and 10 is 2. So 2 over 2 is 1, and 10 over 2 is 5. So the simplest form of 2 over 10 is 1 over 5. The values of n now are 1 and 1 over 5. We are done discussing solving quadratic equation using the quadratic formula and completing the square method. That's all for today. Thank you and God bless.